Okay, I'm on a construction site here, but I set this up for you because it allows the setup. Sorry, pretty hot outside, pretty sweaty here. This is Champlain Towers South, Champlain Towers. And let's talk about Champlain Towers. Rebar, reinforcement, rebar. Got more of it there. This is just a weight, just a piece of 2x material on top of there, roughly 2x. There's more 2x material, not roughly, but more so. And we can put a wall up there. That would be the south wall. We'll get to this. This is my seesaw. Probably won't get to it in this video. And of course, I need a good demonstration for weight, so I grab this product. Do you know that it's great for the immune system? Anyway. Oh, wow. Look at that. Huh. Look at that. So you see what happened when I released it. Down here. Let's see if we can get it to calm down first. Alright, so you're sagging in the middle, deflection in the middle, get you an uplift on the other end. Oh, wait a minute, what's this? A drawer. What's that doing in a way? Oh, it's representing a column in there. Alright. Look what happens when I put load on this side. Huh. There's our hinge point for the seesaw action on either side. So a frequency could get over there. I could get a frequency over there to rattle that wall. Shaking it. Obviously creating fractures and all. We don't have that fractured wall presented in any evidence that the vibration of the park did that. Here it is. I'm just tapping on this and getting this thing to separate. Just tapping a little. Now let's turn the frequency down a little bit. Just a slight tap. Huh. Look at this thing go. No one complained about the swimming pool shaking and doing that. No one did a film of the swimming pool doing that, having these rattles inside of it. These waves inside of it, rather, from the rattling, from the frequency, okay? So now, here's our column, yeah, sorry about that, wipe my skull again, I'm pretty hot. You can use this, you can extrapolate this to be a load, you can extrapolate to be whatever you want, that's dirt, whatever you want. I want you to think of the pier head, the column head here, and there's the reinforcement. As this sags down, it pulls across this side. It's across there, right? It's pulling on the rebar on the other side of the deck, other side of the column, if you will. So that's what I meant by that. So your deflection here is not for free. It has an uplift effect, which has a down force on the head, which creates the stress across the head. Now, if I were to hold this down with a weight, and then I start tapping this, you can see that if this is held down, such as a car, and your sagging is here, your cycle, your stresses are going to be created more on this side, unless the rebar loses grip force internally to the paste, the concrete. So now push it inside there. And see it? You can hear it, right? I'm slipping out. But I had grip in it a moment ago. So now what I did was, let's pretend like this is the other side that you're loading. And you're stressing, pulling. You can see the rebars through here, so you can see what's going on. I want you to understand that when the deflection happens, if we lose grip, I'm going to deflect on this. When I deflect on this, it's going to have a pulling effect internal to the concrete. And it's going to pull on the far end. You see it pull in? And that's when we start getting the fractures are probably upon the head in a rotation at that column area, that column that's over there by the parking garage area. There's your 4x4 for your column. Also over time, I would imagine that this deck deflected and had some tiles that were popping, and that the maintenance guys came out there and replaced them. So NIST should look into that, about the maintenance records. How many tiles did they purchase over the years? The repairs that they probably, as this deck deflected, were protecting, hiding what the evidence of what's going on. The deck was probably had quite some issues. Now watch what I do to the end here. Now I'm going to put the load here, deflection, and we'll watch the uplift over here. Right there at the end, right here at the end. Okay, you see the reaction? And the pivot point is here, isn't it? Now let's go ahead and clamp that down. So now you see it's clamped down. All right. This is the version of the reinforcement coming up and tying in this slab, locking it in place so as you load the center, it doesn't have an uplift. See, the hinge point is still here, but no uplift because now we're locked down. So now our deflection still takes place. Oops. Deflection still takes place, but now it ramps up. If you guys can see that it ramps up. It doesn't just go straight there because it can't, because there's material in the way that has to compress. And you see as I load here, it creates a ramp. It extends from the wall surface, if you will. This is the parking garage below. This is the pool deck. So it extends from or you can change it to the cars area, but I prefer not. Let's just keep it over the wall, south wall, without the parking garage. As you can see, as the deflection takes place, this is still pretty flat over here compared to deflection out here. Over here, though, it's starting to pull down around the 4x4. Let's get this out of the way because we're going to make this fail. I'm going to make it fail, and we're going to get the fracture over here. So I'll get rid of the bottle there. So this is the styrofoam, but now I'll push down, and we're going to get, the styrofoam's got a lot of rotation, a lot of springiness to it. Great. Great. Oh, that's what I'm forgetting. Hold on. Forgot to give you a fracture in the middle. Hold on. The butterfly in the middle. Hold on. So all I did was score the underside as in a tributary area, and that's what they come back and they foam that underside, if you will. But the truth is, it's in the wrong direction. The hinge is still this way. So now we get it to go down. It flex down because it stops. But on this side, wow, you can see how strong it is. Look how much it's maintaining rigidity. But ultimately, oh, okay, I'm getting a lot of compression down there now, so it doesn't want to snap. It's compressing. Need a little more tension on that one. Wow. Okay. So there's our fracture plane. All right, let me turn off that. Turn down the lighting a little bit. So there's our fracture plane. You see what happened there. And it snaps free. It falls down, rust against the wall because the butterfly is butted by the other butterfly locked in. I'm going to post this. You guys, hopefully you'll see that because it was locked in. And now it digs in here and it takes out some material like that. We see that in some of the video. This foam acted a lot more consistent because it was consistently connected. It didn't have rebar as the existing structure would have had this. And a cone, even more reinforcement, if you will, multiple locations, cone. The cone is the end result of what we look at. They would have been at multiple places down this. And they do. They show it. They show as such. All right. Take care. Bye.